All right, folks, welcome back. We've got Natalie Somersall joining us for a gentle intro to container escapes and no-clump gravy. Natalie is a federal solutions engineer and squash merge evangelist, roaming the internet at large. She loves to hike, cook, and make mischief wherever she goes. Natalie, I'm so excited to learn about container escapes and gravy. Take it away, please.
Thank you, thank you. Thank you so much for the kind introduction. And thank you to Leslie and the whole PancakesCon crew for putting this together. Like everyone else attending, I've learned a ton, made new friends, and now that I'm a little later in the day, I'm really hungry after muffins and sushi. So I wanted to talk about two great things that come in boats, and spent a ton of time with AI art generation of container gravy boats. So this is a boat of container gravy. Gravy comes in a boat, and containers have long been visualized as boats. The Docker logo, Kubernetes, and that whole ecosystem, all is ancient Greek nautical terms. It seemed like a natural fit. And as a small content warning, there are pics of insects in this presentation, and there is maybe a little bit of a spicy take from a salty sysadmin. So hi, I'm Natalie. I like to talk to the feds and defense folks about containers, application security, and secure software development kind of as a whole. I did the thing for real at a big systems integrator and decided working with people was way, way, way more fun. And I love to cook. So we're going to end this presentation even a little bit more hungry maybe than we went in. And I don't know everything. It's super humbling and exhilarating to have things that kick your butt and make you learn even more. Um, Tiny disclaimer, these are my opinions, not past, present, or future employers. And slide, link, code, all of that for today is already published. And there's my socials if you're interested. I have some biases that I really like to start out with. Even if they're not too relevant for today, I do work in a technical sales role in the AppSec space. And I really, really love tasty food. Everyone has to eat, and so you may as well enjoy it. Making and sharing food with someone is a great way to show you care and have a great conversation. And we'll see this again and again. Making the right choice easy enforces good habits. It's great for eating healthier, but it's also good for application security. So a ton of security and systems administration courses and developer courses talk about a container escape and how it's super scary. But what is that really? So we're going to go over a little bit about what a container is and how it works, demonstrate how to escape from it with two things that I've found to be pretty common in the field, and talk a lot about ways to prevent this exploit. But first, what even is a container though? And despite the left to right showing progress here, these are all three 100% valid ways to build and run software in 2024. All things have trade-offs. Originally, the only way to do this, though, was that far left one, where you had servers and racks, normally called bare metal. And for maximum efficiency and utilization of all of that hardware, you could run multiple apps side by side. This got to be a little bit of a problem because you would have to own your peak capacity and operate that. So you would have to be able to say, hey, I know that on Saturdays and Sundays, my capacity is twice what it is during the weekday. So I need to have this much hardware and not this much hardware. But it gets a little harder too. What happens when we need to isolate the apps from each other? Or if one app takes too much resources and it starts affecting the performance of the other things that are located with it. And then the really, really hard one, the one that has given me gray hair, is when each app needs a different version or of a component in the operating system. So think one needs Python 3 and one needs Python 2. It can be a little hard sometimes. The next big leap forward here was in a virtualized deployment or virtual machines. And each application can then have its own OS. And these can stack in those same big beefy servers in a data center for efficiency. And these pretend to have their own hardware. So you can figure out how large or small a VM needs to be. Escaping it can be quite difficult, but it is possible. There was an named CVE earlier this month for VMware that made an out-of-band patch, so super duper big problem there. But all in all, we don't really talk about VM escapes as often. And you can orchestrate them across those big beefy machines with the things that you might be familiar with already. Things like the Linux kernel's KVM or Hyper-V or vSphere. Okay, but that's a lot of overhead. What if we could reduce that, but still keep those isolated dependencies together and still be able to set resource limits? Now you're thinking in containers. But we're going to rely on that operating system to manage resources and isolate those dependencies. And again, we can orchestrate them with things that you've probably heard of already. Kubernetes, Docker Swarm, HashiCorp Nomad. And for an escape, that red arrow is going from that container downward. So that's our escape path. And then we're going to explain using that blue path. We're going to go bottom up for explanation. So I said we might have had a trade-off here. A container is a process. It's not that different in some ways than that bare metal deployment. Except if a container is borked, you can just restart the container. I remember having to reboot bare metal machines and waiting a very few uncomfortable minutes of wondering if I needed to go like physically fix something. So that container as a process paradigm is great. And it gives you some special guardrails and abstractions for making developing software easier than those other two options. But it's usually not something you keep around forever. Again, all things are a trade-off. And we're not losing all of that isolation, especially if we're careful about what a container is and how it works. We've talked about it as it's a VM. It's just an app that's running its own thing and you don't need much more. Well, it's a process. So we're going to move bottom up, like I said. And at the very, very bottom of that diagram, where the hardware and the operating system talk, are system calls. You want to read a file? That's open and read. And if you're nice, close at the end. You want to read to the network or write to the network? That's socket and friends. There's hundreds of these. Do you need hundreds? I'm going to take a wild guess here and say no. So we're going to talk a little bit about secure computing, and that's there to enforce those limits. Introduced in the mid-2000s, it's been part of the kernel for a long time. It's quite stable. And I like to think of it as an electric fence for processes. As long as you stay in bounds, not a problem. Try to touch the outside, instant death. Huge fan of instant death when we're starting to talk about defensive computing. And it can read the files it's already got open. It can exit nicely. You can do a lot with it, but not a lot that you weren't prepped for. Okay, so you didn't want to become a kernel expert today. And that's totally fair because we're not going to be experts in the next 20 minutes. These guardrails are all a combination of Linux kernel features and tools in userland, so tools that are outside of the kernel. And continuing on that bottom up path, we have namespaces, C groups, capabilities, and overlay FS. So roughly speaking, C, have, do, and how that file system works for how it can bring its own dependencies with it. And lastly, no container security talk, or honestly, any Linux security talk is complete without touching on AppArmor or SE Linux. And they are watchdogs. They make sure that each process, container or not, is only touching the resources it's allowed to. First up are namespaces. There's 8 of them. At a high level, C groups, IPCs, mounts, networks, processes, time, UTS, and end user. And in that bottom corner, I put a little screenshot of what that means to pass one of those namespaces in. So you could see that if I pass that host namespace in, it sees what the namespace is. So it sees, hey, my host name is demo. In this case, that's not very helpful. But what is helpful would be, hey, if this is database server 3, I know now that there are at least 3 database servers, where if I don't pass that in, I just get this random user ID or random container ID. Minimizing what that process can see minimizes your attack surface, and it reduces information exposed for a living off the land attack. Let's look at one of those in particular, that control group. I like to think of it as a weird file system. It's mounted at sysfsc group for the most part, and it defines what a process is allowed to have. So if you're telling a process, hey, you can only grow to 2 gigabytes, that's the actual how that happens. Ideally, you and I as human beings aren't performance tuning or rate limiting individual applications. For the most part, the sensible defaults are already in place, but you can restrict them or remove them if you really want to. But more importantly, this provides that ability to consume all of the resources in the system. So if you escape and are messing with this file system, now you can have that denial of service attack. So again, in Unix, all things are files, which means that if we escape and start writing to the file system, this is one of those ways we can do that. And here's where we finally get really dangerous and fun. Once upon a time, you were either an all-capable administrator, you were root, you were able to do everything, or you were a plebeian with no special powers. So users had no power, and you were always, hey, sudo make me a sandwich. Sudo, go do me a thing, or becoming root and doing it. That binary all or nothing approach has been, I'd say, replaced, but honestly, in some ways supplemented by capabilities, and those define what a process is allowed to do. So some of the really fun ones, netbind service. So if you want to run something on a privileged port, say 8443, anything below 1024, that's the capability you need. If you want to read the kernel's audit log, that's that second one, cap audit read. And we're going to talk a little bit more later about cap sys ptrace, so the ability to interact with the host's memory, and cap sysadmin, which is basically giving it everything. There's 40. We're not going to go over all 40, but be careful out there, because this gives us more of an escape path once we're starting to look at that container. Or, you could just break this whole process entirely because you're running everything as root. And the fun police are here to stop some shenanigans. I said no container security talk would be complete without mentioning AppArmor or SE Linux. They're called mandatory access control. And I put context in big and yellow font because it is context-based controls. So it looks at your process, and you can only touch or do the things based on the user, the role, and the context that you're trying to do. And it's super common to disable them still. I really wish in 2024 I wasn't saying, please don't disable SE Linux, but here we all are. The reason is it's usually the top thing when you start searching for something. It's like, hey, I have this error message. What does this mean? What do I do? And the first answer on Stack Overflow or the most upvoted post on Reddit is, here's how you disable it. I asked a popular AI coding assistant how to fix that error message as well. So I just copy pasted an AppArmor error message, and it gave me beautiful, detailed directions, step by step, of how to disable AppArmor. And then told me at the very end, like, hey, you may want to ask your security professional or systems administrator if this is a good idea. So naturally, we'll be disabling those for our demo. A container is a Linux process. Understanding those restraints and how they work is critical to understanding how they can be misconfigured or how they fail. This is how you gain that foothold and move around past where you're supposed to be. That's our escape. Because it can be hard to understand, it's likely easy to do insecurely. And there continues to be a ton of work in this space. It used to be when I was starting to learn containers and containerization that the Docker daemon always ran as a service and it always ran as root. That's no longer the case, and that's not even the recommended default anymore. You can now run a daemon as root. There are other container runtimes like Podman that don't use one at all. And these sensible defaults are the most secure, or sorry, the most powerful tool for those systems. That's improving our security. So I had to ask an AI art generator what a container ship full of gravy boats looks like. And this was simply too good to not use. Let's imagine we put a ping pong ball in one of these boats, representing a user or user input. Bit much for a metaphor, but bear with me. How secure is that ball in that gravy boat? Is it hard for the ball to roll or bounce between the boats? What if we're in rough seas, or we put a lid on top, or we glue the ball inside? It's a lot harder to get out. And those are our escape configuration safeguards we just talked about. Widely speaking, there are two paths out of a container. You can have unpatched vulnerabilities or unsafe configurations. And the first is what we typically imagine when we talk about container escapes. It's a flaw in the container runtime or the kernel that allows a process to do unsafe things, like read or write to other processes or the file system or anywhere beyond what it's allowed to do. And these are scary. They get cool names and they get numbered CVEs. And there are amazingly smart researchers and bounty hunters doing really cool stuff here. And again, cool names, leaky vessels, effects, run C and build kit. I can't make up a cooler name than that for a container escape. And there's always something. I tend not to focus on these though. They're usually patched pretty quickly after disclosure, and you remedy them by updating your software. Oh, wait. This is the I used to be a sysadmin and I'm still maybe a little salty about it. If updating any part of your software stack scares you, fix that first. It's not doing more with less. It's not being lean and agile or delivering value to shareholders. You're hiding the financial and business continuity risks of that system failing. So if the thought of touching anything in that software stack makes you uncomfortable, listen to your gut, fix it. Update the documentation. Um, have a good systems inventory. Have the ability to test, deploy, and roll back changes. Technical debt, like real debt, accumulates compound interest. And having been on the, oh no, we rebooted a server and now are massively lift and shifting it because we have no idea how to bring it back up. If you make little monthly payments of resiliency on your technical debt, it pays dividends. And that's the end of my spicy take. So let's talk about unsafe configurations. A mentor of mine told me years ago that there's no patch for human stupidity. And yes, that is true. I don't see outright stupidity all that often, though. What I do see all the time is expediency to meet a deadline, under-resourced teams, maintenance windows that are so far apart you're really hard to keep up to date. So many things to fix that you never start. And I hate to say that the red team aspect of this doesn't care, but I don't need to be clever to exploit misconfigurations. Um, if you Google how do I fix this error and it's told like, hey, I just turned this off. Okay, then like you've turned it off. Even better is there's almost always a valid business case some of the time to do these things. And I found out that workplace safety and InfoSec have a lot in common. And that's stopping this guy from harming himself or others because DANGR definitely spells shortcut. So let us pray to the demo gods real fast and share a terminal. All right, you should see a terminal. Let's go ahead and make a flag. Alrighty. We're going to make a flag and boop, there it is. Hiya, you found me. And let's go ahead and mount that host's file system. Walking you through this line by line, we're going to run a container interactively and with a terminal. This is super common for debugging, development. We're going to drop all capabilities, but we're going to add back the thing that we need. So which is, in this case, sysadmin. We're going to disable AppArmor because of course we are. And then we're going to mount or share through the devices into our container. So this would be super common if I knew I had some data somewhere that I needed to work with, or some hardware that I needed to work with. And here I am inside my container. So let's go ahead and look at our block devices. There's some loopback devices. I'm not sure what those are. Maybe probably not all that interesting. I bet you these down here at the bottom, these disks are interesting. So I'm going to go ahead and mount VDA2 over here. And let's go ahead and cat out that file. Hey, here we are. And I'm going to go ahead and append to that just for giggles. And here we are with Ubuntu. All right, so let's go ahead and exit and just look at that flag. Uh-oh. Now, if we intended to do this, I wouldn't be all that upset about it. But if we were running this in production, I might be a little upset about somebody trying to talk to the host from a container. Let's go ahead and try to do this from, I'm not just picking on Ubuntu here. Here's a different container, more or less doing the same thing. So in this case, this is Red Hat's UBI. And it doesn't matter what container you're in. If you're giving me a shell and you're passing me stuff, I can make all manner of mischief here. So there's that boot drive again, and we can mount it. And let's go ahead and just add to it. Alrighty, that's still not all that great. So let's talk a little bit about what and where and why this works. So a few naughty things we could get into once we've started looking at the host's file systems is we could start messing with etc hosts or etc resolve conf to establish connectivity to a malicious server without anyone looking at a DNS. We could get passwords out of etc shadow or start messing with login assignments in etc password. We can replace a trusted executable with something that's already compromised. We have access all over the file system. In general, not a great thing. But let's dig into a few places where this could have been hard to pull off. We ran the container interactively. We ran it with a terminal. We gave it administrative privileges. We disabled SE Linux, making me a very sad panda. And while there may be good reasons to mount a file system from the host inside a container, mounting all of dev is probably a little too much. And by probably, I mean definitely a little too much. Because this gave me access not just to maybe the directory that I needed, but it gave me access to the boot directory or to anything else that I wanted. Again, this is probably something that might be okay in experimentation, but not revising these settings as a project matures, removing that shell, not giving it privileged access is something that we need to think about before we start moving things to real users that might be attacking things. And our next demo is going to be a little different. We're going to go ahead and write to the host's memory from that container. So let's look real fast at our Docker file. So there's not too much going on here. We are installing GCC because we need to compile some software, and we're copying a file in. Let's look at that file real fast. So I want to call out the source here, and then I've edited it to bind to port 5600. So we are injecting shellcode into a process in memory. So let's go ahead and quit that. We're going to start an HTTP server. So don't need to do anything fancy here. And I'm going to note that PID 10615. And let's do a quick NC real fast just to make sure that that's up. Not that I don't believe it, but I don't believe it. Hey, here we go. 8080, the port that I launched it on is here. And as expected, 5600 doesn't work. So let's go ahead and launch our container and compile our code. And then .whack inject 10615. All right, so we have overwritten part of the memory here, and I should see that we are now listening on 5600. So here it is having succeeded. And oh no, as expected, but not as desired, we have a new port listening. Not a great thing. So I'm going to stop that share and start sharing my slides again. So a good way that this could be used is there are totally valid reasons to be containerizing your development tools and to be able to access hardware on the host, including maybe memory. But here's where this kind of went wrong. So we added the ability to do that. We disabled AppArmor, and we allowed the PID namespace, so that process identifier, to be shared between the host and the container. So we didn't give it a boundary saying like, hey, you can only talk and look and read at your processes. You're allowed to see quite a lot. Again, this could have a great use in development, but you probably need to revise this before you set malicious people, or honestly, just real chaotic people, loose on your containerized app. Be mindful of all of these capabilities. So using privileged or adding the sysadmin capability is risky. Turning off SE Linux or AppArmor is risky. And then what I didn't really show was the ability to add a security option called no new privileges. So what this does is you can start with this set of privileges, and then even at runtime, you're not able to add more. And these sound simple, but they're super common in very specific use cases. Continuous integration, building a container inside of a container. Hardware development, debugging, and a lot more. Using the non-root user within your container is super handy. Use trusted images that are rebuilt regularly with those security updates. Keep your hosts up to date too. But most importantly, revise your dependencies between development and production. Each of these practices are imperfect, but they prevent quite a bit of naughty escapades and malicious actors. Together, all of these combine into a formidable system that can be forgiving of one or two of these deviations without a huge impact on the system. This is defense in depth. And here are some resources to learn more. And again, I put all of them in that bottom link because it is super hard to put lots of links on a slide. But let's talk about that other boat, the fun boat, the gravy boat. Everyone has gravy. My world was absolutely transformed when I figured out how to make gravy. Family holidays might have become a little easier too. And there's a balance of ingredients for perfect pan gravy and a couple techniques to recover just in case it wasn't right the first time. There are a lot of types of gravy. I started listing them out and then realized I sounded a little familiar because every culinary tradition seems to have some sort of recipe to use up the last of the pan, to make things that might be not so great on the ingredient list and cover up those shortcomings and tie a meal together. Gravy's the glue of the world. So you have a pan gravy to deglaze a roast. So you have all of that lovely brown bits at the bottom of the pan, how to make a gravy out of that. So that's what we'll be talking about. And then we'll also talk a little bit about sawmill or sausage gravy, which is the traditional biscuits and gravy. But there's so many more. Food brings people together, and gravy can bring your meal together. And like I said, I was solidly on the struggle bus for gravy for a very long time. And everyone seemed to just know how to do it. And I was always messing it up. Like it was too salty or too thin, or it was so thick it kind of looked like Jello and it was gross. Um, and lumpy. I hate lumpy gravy. And it's a really simple combination. Fat, starch, water equals gravy. But while it's simple, there's some really easy ways to mess it up. I'm talking about lumpy gravy, the plague of the dinner table, and maybe the source of some of my embarrassments over the years. So let's do a little bit of science and never suffer with lumpy gravy again. All right, there's the enemy. Quick warning, the next slide has bugs on it. 3, 2, 1. Awesome. Um, let's talk about what causes lumps in gravy. That is not an island. That is not random bits of flood debris. That is a raft of fire ants adrift in the water. When the water table rises, fire ants leave their nest. They carry their young and their queen with them. Then they form these nightmare islands on the ground surface. As floodwaters rise, the fire ants can move to a new home, but they have a chance of survival by acting together versus individually. Fire or flour, like fire ants, also acts weird when it gets wet. Because flour is a lot of different things. It's a finely ground grain, usually the seed of a plant, and it's mostly starch. Starches love water, and when they get wet, they start to expand like a sponge. Flour also has some fat too. It's normally what's responsible for making it smell funny or go rancid. And flour also has protein. In the US, most of our flour is based on wheat, normally without any bran. And that protein is what forms gluten when it gets wet. So like I said, bran, that seed has several parts. Bran is that outer husk that's full of fiber that protects the seed. Endosperm is fuel for the new plant, and that's mostly starch. And the germ is the protein and fat and B vitamins. That's what's going to make that new plant. You can get super duper deep into the science of baking, and that might have been my new exploration of late. But everything today, we're going to talk about all-purpose flour. So when ants get wet, they lock together their jaws and legs. This increases the surface area that they have, but it decreases the density of the whole like ball of ant so that they float as a whole, but sink individually. And they use the surface tension of the water to lump together. So even if you kind of push down on that little raft of ants, they're starting to displace water. When flour gets wet, those three components we talked about of flour start to interact in ways that form lumps. The starches start to swell with water and act like a sponge, and the proteins start to bond together, forming a surface that holds the lump together. And heat makes these two processes happen faster, usually much faster than you can whisk them out physically. Where this gets tricky is gravy isn't made by dissolving flour into fat and water. It's not iced tea and sugar. Even the smoothest gravy is an emulsion, which means that the flour is an individual particle suspended in liquid. No matter how much you let it sit, it's never going to magically break up those lumps. You want individually drowned ants. You don't want a floating raft of fiery doom. And we are done with bug picks, by the way. So to fix lumpy gravy, the easiest path is to throw it in the blender. It will blend. You can also run it through a sieve if you have a strainer. You can whisk it. A lot of elbow grease involved, but is totally possible. Um, and as much as it pains me, throw it out and try again. So now that we have the science of preventing lumps in your gravy, let's make some. The magic order of operations here is fat, then flour, then water. And that order gets really, really hard if you have a tasty roast right out of the oven that's already hot and has no flour. So you don't want to throw out all of those brown bits in the roasting pan because that is a one-way ticket to deliciousness. Don't throw it out. Deglaze that pan, so put it on a burner, add some broth or wine to scrape up those brown bits into the sauce, and then add your new best friend, roux. Roux is a simple fat and flour mixture that's cooked until it reaches whatever the right shade of done is for you. The flour is done cooking once it stopped foaming. So you can see on that top left picture that there's a lot of foam. That's completely raw flour, just starting to heat up. Light roux is barely toasted, and it doesn't really have any flavor to it. It's not changing the flavor of your dish, especially if you use a neutral fat. If you continue cooking it though, it'll get a nice chocolatey brown that has a lot of savoriness, a lot of umami, but can overpower your dish. So this was roux that I had made for gumbo. There was delicious gumbo in my household not too long ago, and that is like a chocolatey brown when you stop. And there's so many ways you can get flexible here. You can change the fat, change the flour. Just be aware of the smoke point of whatever fat that you're using, because you don't want to burn anything. So if you're feeling decadent, butter or duck fat or rendered beef tallow. And then a super duper cheat code on the bottom left, we're no longer in that pan. So when I got the roux to about this color, it was 400 or so degrees Fahrenheit. Very, very hot, and takes a while to cool to not continue to cook. So to prevent it from getting any darker, I poured it into a dry sheet pan, and the thin aluminum and the wide base meant that it dropped to a safe temp much quicker than I had just left it in the pot. But all right, let's take it up a notch for difficulty and remove the ability to use a blender. Texture of breakfast sausage is really good or really critical to a sawmill gravy. And I highlighted the 3 fat, flour, ingredients, the ratio that we needed. So 2¼ cups of milk, 1/4 cup of flour, and 1/2 pound of breakfast sausage. Cut the casings off. If it's really lean sausage, you might need to add a little bit more fat. So butter, rendered bacon fat, whatever you have on hand. And then work the sausage apart. You'll add the flour. And again, this works the same for vegetables as well, or fat or meat and vegetables. You just want to be able to do your pre-cooking, then coat the flour in the cooked things before you start adding liquid. Stir. The flour will start to brown a bit too, and that's fine. It's coating the sausage and mixing in with the fat in the pan. You just don't want dry flour. So if it's dry, add a little bit more. In this case, I added a little bit more fat. When you first pour the milk in, it'll look super underwhelming and be thin. It would be the same if I was making a pan gravy with roast drippings. When you first put the flour in, it looks a little bland. It takes a little bit of time for that flour to kind of diffuse throughout the mixture and really thicken it. So the last thing to think about here is a spoon test. So you're going to stir your sauce, and then on the back of the spoon, draw a little line with your finger. And that line should stay clear and well defined. So this is an example of a meh, like it's okay, I could serve it. But if I wait a little bit, magic happens. You should see a YouTube video, just like 2 seconds. And refrigerate leftovers for a day or three. There is a cheat code to gravy, and it is a pre-cooked and ultra-fine flour. Packet gravy and many of the dump and stir type meals that come in a box just add meat and water. Recipes use this too. Just be careful. A little bit of this goes a very, very long way. And lastly, let's talk about gravy container security, as this is the most important part of your holiday meal. I asked an AI art generator to give me a leaky vessel gravy boat as a watercolor. But this is a gravy boat. It is good for transporting from your kitchen to your dining room around the table for one meal and no further. The reason is gravy is a fantastic breeding ground for bacteria that cause food poisoning. And so while it has salt content to help it prevent some spoilage, it's also got plenty of starch and it's not very acidic, and it's served at the temperature that's perfect for bacteria to grow. So the USDA says hot food's hot, cold food's cold, and you want to minimize the amount of time between 40 and 140 Fahrenheit or 4 and 60 Celsius, because that's the perfect zone for bacteria to grow. If you want to go farther than from your kitchen to the table, refrigerate your gravy, put it in a cold thermos, and reheat it when you get there. Most gravies reheat fabulously on the stovetop. Thank you so much for the opportunity to share some hard-earned gravy wisdom. I hope it helps you make meals for your friends and family and use containers safely. Keeping it fresh for food and AppSec is critical to success, and I'll be hanging out in Slack for questions. Are there questions now?
So there was one question in the Slack. It's actually
Mhm.
very unwieldy and layered, so I am holding
Uh-huh.
that to answer. You were tagged in it, so I know you'll actually get to see it. Um,
Perfect.
but I have a question for you. Do you have
Yeah.
a preferred shade of roux that you like to use for your gravies? And also, what is your favorite kind of gravy?
Ooh, favorite gravy is still just biscuits and gravy, that sawmill gravy. It's it goes on biscuits, it goes on. Honestly, I put it on like fried chicken as well. I put it on mashed potatoes. Like it can go on so much stuff. And then for roux, I do chocolate, like that dark, dark brown, because you could put red beans and rice in it. You can do like all of the like super deep savory dishes go really well with that dark roux.
Right on. Thank you so much. This has been wonderful. You've inspired me to make biscuits and mushroom gravy for dinner. So really looking
Ooh,
forward to that.
thank you.